Hello everyone. All right, let's solve this SSC 2024 question 4 and 5 theory section A. Okay, past question. So now we have question 4 and we have question 5. Now for question 4 reads in the diagram ABCD is a circle, center O. So we have ABCD. The center of the circle is what? O. Now the quadrilateral OBCD, that is OBCD, all right, is a rhombus. You know, a rhombus has all its four sides equal, all right, so which means the side length of a rhombus are equal. So we also have again that angle BAD, that is BAD is equal to what? T. So which means the angle subtended on the circumference is what? Is what we have here as letter T. All right, so we want to find the value of T, which is the value of the angle subtended on the circumference. Okay, then we're also going to find the value of Y. So Y is the angle ODA and angle what? OBA. Okay, so the size of angle Y, that's angle ODA, is also equals to the size of angle what? OBA. So that's why we have it is represented with the same letter. Okay, now we're also looking for angle ADC. So ADC, okay, we want to measure, we're also going to calculate the angular measure that's between, that's at C, that's angle ADC. All right, so now, then also for question 5 is a question under what? Probability. So it's a question about probability. Now, okay, so we have this question. Now, let's see how we can crack the two questions, okay? How we can solve the two questions. Okay, for the, now, for number four, okay? So we have number 4. Let's take the analysis. Okay, so like I said, now the first thing here is we want to find the value of T. So let's pay attention to, you know, letter T. Okay, so because the first question is that we should find the value of T. Now to be able to solve for T, okay, now we're going to apply some theorems. Okay, some theorems from circle theorem. So we're going to apply them to be able to solve for letter T. Now let's see how that works out. Okay, now when I look at this shape, now we have a quadrilateral. Okay, this is a quadrilateral ABCD. Okay, and when we have a quadrilateral in a circle, then it will be called a cyclic quadrilateral. So now the angle subtended at A on the circumference is what we have as letter T, and that's what we are looking for. Now, first thing, I'll need to set up an equation, okay, using the one of the theorems in circle theorem, you know, an equation between, now there are two theorems I'm going to apply here. Now, the first theorem, now we're going to use the first theorem, okay. Now, the first theorem will be theorem about, now, angle which an arc, okay, which an arc subtends at the center, okay, is twice that on the circumference. That is, we have angle, okay, yeah, so let me use a red pen. Okay, so we have angle which an arc subtends at the center, okay, is two times that on the what? On the circumference. 2 times that on the what? Circumference. So which means angle at the center, okay, angle at the center is BOD. Okay, BOD is the angle at the center. So because BOD is the angle at the center, so we can now write BOD, angle BOD is 2 times angle what? Now, angle subtended on the what? Circumference. Now, we have two angles at the center. There's a reflex angle BOD, which is this angle. Okay, the angle which the reflex angle BOD subtends on the circumference will be BCD. So we're not going to use that. Okay, now Then we also have that, but this other angle, okay, now subtends angle A on the circumference. So we are going to have 2 times BAD, angle BAD. All right. So which means that the angle at the center, okay, the angle at the center, which is BOD, will then be equals to, okay, angle at the center BOD, angle BOD, okay, will be equals to 2 multiplied by BAD. And we know that BAD is what? T. BAD is T. It's here in the question. All right, so that's the first. Now let's say this is our first equation. This is equation 1. All right, please pay attention, okay? Now that's equation 1. Now also another theorem we're going to use in this case is the theorem about a cyclic quadrilateral. That, I said when we have a quadrilateral inscribed in a circle. Now, when the quadrilateral is inscribed in a circle, okay, so we have the vertices, that's all the 4 vertices will lie on the circumference of the circle, A, B, C, D, okay. So the sum of the 2 opposite angles of a cyclic quadrilateral. Now, these are 2 opposite angles, AC, A angle at C and angle at A. They are what? They are what? They are 2 opposite angles. Okay, same with BD. Okay, B is opposite D, all right, or D is opposite what? B. So in this case, so we are going to what? We are going to use the theorem, the sum of 2 opposite angles, all right, in a cyclic quadrilateral, in a cyclic quadrilateral, in a cyclic quadrilateral, okay, are supplementary. Supplementary angles, okay. When we talk about supplementary angles are angles whose sum are added up to 180 degrees. That's supplementary angles. All right, so which means, so it means BAD and BCD. All right, so that is their opposite angle. So which means we have angle BAD plus angle what? Angle BCD. So we have angle BCD equals to 180 degrees. Now we know that angle BAD is what? T. So T plus angle BCD, all right, BCD equals to 180 degrees. Now, so we have T plus BCD equals to 180 degrees. So this becomes the second equation. That will be equation 2. All right. Now, so in this case, we have angle at center to be twice angle on the circumference. Okay. Then also we know that angle, that is the sum of that's BAD and BCD, is equal to 180 degrees. So what we need to do here to be able to calculate T. So now in this case we know that angle BCD is equal to 180 minus T. 180 minus T. Then we know that angle BAD, okay, is twice angle on the what? Circumference. Angle BAD is twice angle on the circumference. So then we know that angle BCD, okay, angle BCD is an angle on the circumference. So we have BOD to be equals to 2 times angle on the circumference. All right, so in this case, remember we added BAD and BCD to get 180 minus T. 180 minus T. So now let's see where, now another thing we need to understand here is that the angle, now this is a rhombus. Okay, this is a rhombus. So now the angle at B and the angle at D, okay, they are equal. I will explain that. And also the angle here, which is the angle at the center, okay, and the angle at C, they are also equal. They are obtuse angle. All right. So now that we know that angle BOD is 2T, angle BOD is 2T. Now let me explain what I am saying, okay, now we have a rhombus. A rhombus is a quadrilateral, okay. Now a rhombus has two what? Two diagonals. That is the line joining the two opposite points in a shape is known as what? Diagonal. So this is another diagonal. This is another diagonal. So the two diagonals makes angle, 90 degrees with that's 90 degrees at the point where they intersect. Okay. Now from the point of intersection to the base to one of the adjacent side of the rhombus. I said this is a rhombus, all the four sides are equal. Okay, all the four sides are equal. So if we have now here, we usually represent this side with what? Letter R, which is the radius of inscribed circle, where R represents radius of inscribed circle. Okay, radius of inscribed circle. All right, so for radius of inscribed circle, so then also if I drop a line from the vertex here to the what? To this adjacent side of the rhombus. Remember, this is a rhombus. Okay, this is a rhombus. All right, so this will be what? Height of the rhombus, and it will make an angle of 90 degrees. That is, it will be perpendicular to this side of the rhombus. So all the four sides are equal, which is why we have these four lines. Okay, so which means this will be A. Let's say this is A, and this is A, and then this is A. So the angular measure between the point of intersection of the two adjacent sides of the rhombus will be represented with alpha. Okay, and the opposite angle here will also be what? Will also be alpha. Okay, but the other two opposite angles are obtuse angle. So we can represent that using what? Beta. Okay, beta. So let's get some informations about rhombus. Now this is very important. It is important to note that now point worth noting when it comes to, okay, points, okay, worth noting when it comes to rhombus. Roman numeral 1, okay, alpha plus beta is equals to 180 degrees. So which means the sum of the angle between the two adjacent sides, okay, at their point of intersection, and the angle between the what? Between the other side of, that's the two parallel sides, okay, that's between one of the parallel side and one of the adjacent side will be what? 180 degrees. Then second point, the square of diagonal D1 plus the square of diagonal D2, okay, raised to the power, that square of diagonal D2 will be equals to 4a squared. Will be equals to 4a squared. That's the beauty of mathematics. There's no formula we use in mathematics that does not have what we call, does not have proof. There are theorems to prove all of this. Maybe in one of my in some of the videos I'm going to reel out, okay, in the coming days, I'll be showing proof on how to, on some of this, about this, some of these formulas. Okay, all right. So now that's for now. Again, we also know now we also have the height. This is the height. When we drop a perpendicular, that's a line from the vertex to the base or to one of the side of the adjacent side of the rhombus. Then the height, that will be the height. So the height is one side of the what? One side of one of the adjacent side, this side. Can you see we have a right triangle? Okay, so this is opposite. This is what? Hypotenuse. So when we express h in terms of a, it will be h equals to a sine alpha, which is the angle between the point of intersection of the two adjacent sides. That's h. Now for the inscribed circle, the radius of inscribed circle is always measured to be half of the what? Half of the height of the what? Rhombus. Half of the height of the rhombus. So in this case, so now to measure the height of the height of the rhombus can also be given as the product of the two diagonals of the rhombus over what? Over the product of two and the one of the adjacent side, of the rhombus. So in this case, this is going to be, so we're going to have this to be D1, D2 all over 4A, okay, where H is what? D1, D2 over what? 2A. All right, so that's that. All right, so but when it comes to calculating the area of a rhombus, that will be D1, D2 over what? Over 2. That's when it comes to calculating the area of a rhombus. So now, this is just for us to, you know, we only need one item from here for us to be able to solve this problem. So like I said, this is 2E. We have this to be 2E, 2T rather, now 2T. And I said the angle here and the angle here, they are equal. So which means angle BCD is equals to what? Angle BCD, okay, is equals to angle BOD. Is equals to angle BOD. So what is angle BOD? 2T. So this will become 2T equals to 180 minus T. Remember, this is because of what we have here. That's a rhombus. Angle BCD equals to angle BOD. Angle BCD equals to angle BOD. So we want to solve for letter T. So I'm going to move this guy from the right hand side to the left hand side. So this becomes 2T plus T equals to 180 degrees. So we have 3T equals to 180 degrees. When we divide both sides, remember, as a WAEC student, remember, this is very, very important. Now, you must state your reason when you are showing, when you want to divide both sides. You must state your reason. Why are you dividing both sides by the same number? Okay, but in this case, it is important because of the space. I want to, let's manage the space, all right, on the board. So all right, so when we divide both sides by 3, the value of T, okay, the value of T will be what? 60 degrees. So this is the value we are looking for. Okay, this is the value of T. All right, so now, so we just solved the first problem. That's A. Now for B, we want to find out what is the value of Y. To be able to calculate the value of Y. So now, first of all, we know that T, the value of T is now what? 60 degrees. So we know that 2T is BOD. Remember, 2T equals to BO is equals to what? BOD. And we have T to be what? 60 degrees. So which means BOD will be equals to 2 multiplied by 60 degrees. So that BOD will be equals to 120 degrees. Now, we know that the distance from the center of a circle to the circumference is what we call radius. So that means when a line is drawn from the center of a circle to touch the circumference, the length of that line will be called radius. So it means that then, now that means if we have this to be radii, okay, then this triangle, okay, this triangle will be an isosceles triangle. And we know that when it comes to isosceles triangle, okay, these two angles will be what? Equal. That's the base angles of isosceles will be what? Equal. So which means BOD, so we're going to what? We're going to use, so for the isosceles triangle, so we're going to use BOD, this angle plus angle OBD, then plus angle ODB, and that will be equals to 180. That will be equals to 180 degrees. That will be equals to 180 degrees. Now, that's equals to 180 degrees. Why is it equals to 180 degrees? Because we know that the sum of angles, okay, in a triangle add up to what? 180 degrees. Remember, the reason, sum of angles in a what? In a triangle add up to 180 degrees. So don't forget that I said OBD. Remember, OBD, okay, equals to ODB. is equals to ODB. They are what? That is base angles of what? Of isosceles triangle. So which means if we decide to, so which means we have BOD. BOD is what? 120 degrees. Can you see? BOD is 120 degrees. Okay. So BOD, let's do this way. BOD plus OBD. So we have OBD plus ODB. That will be 2OBD. That's equals to 180. So we move this guy to the other side so that 2OBD will be equals to 180 minus 120. So 2OBD will be equals to, so 180 minus 120 will be what? 60. So that OBD can be equals to, that's OBD can be equals to, so when we divide both sides by 2, remember, write your reason. So divide both sides by 2. So we're going to have 60 divided by 2, and that will be equals to what? 30 degrees. That's equals to 30 degrees. Now, so now that we know the value of OBD and we know the size of this angle to be 30 degrees, and we also know the size of this angle to be 30 degrees. Okay, so we now have another triangle. We have this triangle. Okay, we have this triangle. So this triangle ABD. So in triangle ABD, now listen, we know that BAD. Okay, BAD is what? BAD is T. BAD plus ABD. ABD. Then plus ADB. ADB is equals to 180 degrees. The reason, sum of angles in a triangle equals to 180 degrees. So now, so we want to calculate the value of y. So ABD will be, that is ABD. Okay, we have BAD, that's T. So what's the value of T? T is what? 60 degrees. Okay, now ABD, that will be y plus 30. So we have y plus 30 degrees. Then also we have ADB, which will be what? Y plus 30 degrees. And that equals to 180 degrees. So that this plus this plus this, that will be 60 plus 30, that will be 90, plus 30, 120. Then y plus y, that will be 2y. So we then have 2y to be equals to 180 minus 120. And that will be 2y equals to 60. Okay, so that the value of y, when we divide both sides by 2, is going to be 30. So dividing both sides by 2, y equals to 30 degrees. So we just found the value of y. That's B. This guy. Okay, this nice guy. The value of y. All right, so now, moving on. So we want to again find DAC. All right, to calculate DAC, that's C. To calculate DAC. To calculate ADC. All right, to calculate ADC, this guy, to calculate ADC. Now, to be able to calculate ADC, we have for ADC this whole angle from here down like that. So we want to calculate ADC. So like I said, remember from rhombus, the entire angle here, okay, plus the angle here, they are equal to 180 degrees. Remember, for the rhombus, now from the rhombus, we have this guy plus this guy, okay, to be equals to 180 degrees. So the whole of this guy, so we know that alpha is equals to y plus 30 degrees. So let's say this small angle here is K. So we put K here. All right. So plus, remember that what is BCD? Okay. Now BCD, okay, BCD. You know, when we say this is what? This is 120. Angle at the center is 120. That's 2t because t is 60 degrees. So 120. So if this is 120, so the reflex angle will be 240. Am I right? So angle at the center is twice angle on the circumference. So which means we can say here that reflex, reflex BOD, which is angle at center, equals to 2 multiplied by BCD. 2 multiplied by BCD. Now, BOD, remember, to calculate BOD, we know that 2t plus BOD equals to 360 degrees. Now, 2t is what? 120. Remember, this is 120 degrees. So that BOD will be equals to 360 minus what? 120. And that will be what? 240 degrees. Okay? So, I'm sure you got this. Okay? So, you copy this, right? So, that will be 240 degrees. So this will be 240. So we put 240 degrees to be equals to 2 BCD. Okay. All right. So when we divide both sides by 2, there's a way I'm supposed to do it, but this is also fine. So we have 120 degrees equals to BCD. All right. So now the sum of this angle and this angle, like I said. Okay. Okay. So mistake. Now, this is what I am talking about. We need this angle. Sorry, the angle at, okay, we are looking for ADC. Yes, we are looking for ADC. But this angle, this is angle alpha. Angle alpha will be 30 plus K. Okay, that will be 30 degrees plus K. Okay, yeah, this angle, just this angle, but this is what we are looking for. So this small angle will be K. Now we know this to be what? 30 degrees. All right, so that means that, so 30 plus K, we have 30 plus K plus BCD equals to 180 degrees. BCD is 120. So 120 plus 30, that will be 150 degrees plus K equals to 180 degrees. So that K will be equals to 180 minus 150. So the value of K is what? 30 degrees. So this angle is 30 degrees. So if you want to calculate ADC, so ADC is now this whole angle here. So angle ADC, that is angle ADC. Yeah, angle ADC will then be 30 plus 30 plus 30 plus 30. So 30 plus Y plus K, which will be 30 plus 30 plus 30. And that will be what? 90 degrees. So that we can say that therefore angle ADC equals to 90 degrees. Angle ADC equals to 90 degrees. Okay. And that is the solution for question 1. Now, we have another question, which is question number 2. Now, this is a probability question. You know, probability means mathematics of chance. That is, probability measures the extent to which something is likely to happen. Or we can say, now, if we have an event, okay, the probability of an event occurring, that is the chance of an event occurring, okay, is what we measure when it comes to probability. And another important thing is the values of probability lies between 0 and 1. That is, probability values range from 0 to 1. So now let's look at this question. A basket contains 3 gold plated marbles, 4 diamond marbles, and some silver marbles, all of the same size and shape. So now that means in the basket, okay. Now for 2, now we have analysis what? Of question 5. All right. So now we have number of, let's use set. So we have number of gold plated marbles is what? Is 3. The number of diamond plated marbles or diamond marbles, number of diamond marbles, okay, is 4. But number of silver let's represent that as K. Let's represent number of silver as K, because we have here that some silver marbles all of the same size and shape. Some silver marbles all of the same size and shape. All right, so now in this case, so which means the sample space, which is the list of all possible outcomes, will be, so we have our sample space to be 3 plus 4 plus K, and that will be what? 7 plus K, all K. All right, so now two marbles were drawn from the basket at random, one after the other, all right, without replacement. So when it comes to without replacement, okay, the first ball that will be drawn, okay, from the basket, okay, selected from the basket, okay, will be replaced, but the second will not be what? Replaced. So now, if the probability that the two marbles were all silver, okay, is X is 1 over 15. So the probability of getting a silver, so we want to find the number of silver. So I represent number of silver to be what? K. So which means now, according in probability, now the probability we want to now the probability that the two marbles were all silver, that means silver, silver. Okay, that will be, if the first one, that means first, okay, is a silver. Okay, we have first to be silver, okay, then multiply by without replacement. So now I'm sure some of you will understand what this means, okay. So we use this in probability, in now when it comes to without replacement. When it comes to without replacement, now I'm going to show you what that means. Now S is silver, okay, and we also have when that, so when during that's the second time the two balls were drawn, two marbles were drawn, so without replacement. So the first one will be replaced, the second will be what? Will not be replaced. So we subtract one. That's what it means. Okay. So which means in this case, we then have probability of it being a silver will be what? K over what? 7 plus K. Then that's the first, during the first drawn. So the second drawn, it will be K minus 1 over K plus 7 plus K minus 1. So we what? We decrease the numerator by 1, and again decrease the what? Denominator by 1. So, and they said that we are given here that if the probability that the two marbles were all silver is 1 over 15. So these two marbles, the probability, okay, our P, S, and S is what we have as what? 1 over 15. That is when the first ball is a marble and the second ball is a marble. So this will be equals to 1 over 15. All right, so now let's simplify this. So here we have what we call algebraic equation. So we can multiply the numerator. Okay, so let's reduce this. So we have the left hand side to be 1 over 15. So this will be K times K, that will be K squared. K multiplied by 1, that will be K. All right, so this will be K, 7 plus K minus 1, that will be 6 plus K. So we then have this to be 7. Now let's do what is 7 plus K multiplied by 6 plus K. Okay, that will be 42. Then 7K, 6K, that will be 13K plus K times K, that will be K squared. So this is going to be K squared plus 13K plus 42 plus 42. All right, so now then we can now cross multiply. Okay, we can cross multiply. So when we cross multiply, this will come to the left hand side and become K squared plus 13K plus 42. 15 times K squared, that will be 15K squared. Okay, 15 times negative K, that will be 15K. So we can now combine like terms. So let's move everything on the right hand side to the left hand side so that we can have a quadratic equation. So we then have this to be now 15K squared minus K squared. That will be 14K squared. Okay, now negative 15K. Now when this goes to the other side, the positive sign will turn to negative sign. So it becomes minus 28K. So this will become minus 28K. So I'm going to move 42 to the other side. So that will be 42 equals to 0. So here we have a quadratic equation. A quadratic equation. So now, this quadratic equation, okay, we can see here that the leading coefficient, the coefficient of k and the constant, they have a common factor. That's the same number can divide 14, 28, and 42, and that will be 7. So if we divide, if this equation is divided by 7, then this will reduce to 2k squared minus 4k, then minus what? Minus 6 equals to 0. Wow, we can still reduce it, okay? 14 divided by 7, that's 2. 28 divided by 7, that'll be 4. 42 divided by 7, that'll be what? 6, because 6 times 7 is 42. So we can also divide this equation by 2, okay? So when we divide this equation by 2, we're going to have k squared minus 2k, okay, then minus 3 equals to 0, Now, let's see if we can factorize this equation. Now we have 1k squared minus 2k minus 3. That will be, so when we multiply the coefficient of k squared by negative 3, that will be negative 3. Okay, so the factors will now be minus 3 plus 1. Okay, so this is going to be, we have k squared minus 3k plus k minus 3 equals to 0. So we can break this into 2, k into k negative 3, then plus k into, no, plus 1, okay, k into k, so we have plus 1 into k negative 3 equals to 0. So we have k plus 1, okay, k plus 1. So for k plus 1, we have k plus 1, product law of that. So we also have k minus 3 equals to 0. So we have k equals to negative 1. So this is not valid, or k equals to what? 3. So the number of silver marbles, okay, would then be 3. So k equals to 3. K equals to 3, which represents the number of silver marble, which is the what? Number of silver marbles. So if we have k to be 3, so it means that the sum, so the sum is going to be, so the sample space, okay, so the sum is going to be 7 plus 3, that will be 10. 7 plus 3 is 10, and it gives us the probability of obtaining, silver. The first is a silver and the second is a silver, to be 1 over 15. So if we want to obtain, now let's put it here. Are we going to get 15? If I put 3 here, okay, let's check. Now let's do that here. So we have k over 7 plus k, that will be 3 over 10. Okay, now also we have k minus 1, over, that one is 6 plus k, that will be 3 minus 1, that's 2. Now 6 plus 3, that's 9. So when we multiply these two, 3 over 10 multiplied by 2 over 9, okay, so this will be 2 here, 1, 2 here, 5. Now 3 here, 1, 3 here, 3. So what we have here is 1 times 1, okay, 1 times 1, and 5 times 3, that will be 15. And this, okay, this shows that our solution, that's the solution to the question 5, is correct. Remember, the quality of your preparation will always determine the quality of your performance. So get starting, and don't forget that the more studying you did for an exam, the less sure you are as to which answer they want. So the more you read, the more you discover your ignorance. And to be ignorant of one's ignorance is the malady of the ignorant. Bye bye.